Eight Rivers is a climate technology company. We're leading the energy transition and we're inventing and commercializing technologies that are both sustainable and commercially viable. The heartbeat of our business is CO2 and the use of that CO2 as a working fluid. Over 16 years of technology development, including the groundbreaking Allam-Fetvedt Cycle, and with over 600 patents to our name, and over half of those being in CO2, we have turned the problem into a solution, and we're now delivering that solution across the globe to blue chip companies and blue chip projects in clean energy, clean fuels, and industrial decarbonization.
Your trusted source for information on the energy transition. This is the Insider's Guide to Energy podcast. Welcome to the Insider's Guide to Energy. I'm your host, Chris Sass. Today, we're going to talk carbon capture, and with me is the COO of Eight Rivers, Steve Milward. Steve, welcome to the podcast.
Hi, Chris, and thanks for the invite to join you today. It's really good to be here, really good to be able to speak to everybody about what we're doing at Eight Rivers.
I am excited to have this conversation because I think you're doing something a bit unique and a bit different. We've done some carbon capture in the past. In fact, we've had Eight Rivers on in the past, but today's conversation is different. You made an opening statement talking about capturing CO2 and doing something with it. Why don't we start with what it is we're going to talk about?
Yeah, it really, at the heart of everything we do at Eight Rivers is CO2, and CO2 is the problem that everybody is looking to solve, but we look at it completely differently. And all of our technologies really are around Oxy-Combustion, one way or the other. When you look at all of the technology portfolio of Eight Rivers, everything at the heart of that is Oxy-Combustion. And when you burn natural gas and oxygen with CO2, the product that you get out the other side of that is hot CO2 and water. That's essentially what you get. So you already have created the CO2. So now that you've got hold of the CO2 and that CO2 is extremely hot, you either use that CO2 to generate power in the Allam-Fetvedt cycle, or you can use that CO2 in a reforming process to create other chemicals. Or there are other means of using the heat in that CO2 and recovering that CO2 and using that CO2 in a process and harnessing that CO2 that you already have captured and putting it to good use is a really efficient use of that CO2 before you then surrender it for sequestration. So rather than other technologies and other companies that look to address the problem at the back end of a system, like a power plant where you look to strip out the CO2 with amines, we've actually created the CO2 in the first place, used that CO2, and then sequestered or surrendered that CO2. And that in itself is a different way of looking at the problem, because you've looked at the problem from first principles and created something new. That means you don't have high capex and economics that don't work at the back end of a power plant or of a steel mill or whichever process that you're looking at.
So help me understand this a little bit better. You're saying in the front end, you're creating CO2 or hot gas, basically, that you are able to use. Are you saying that a power plant would do this on the front end and use the heat from the CO2 to turn a turbine? Is that what we're trying to say?
Yes. So if the Allam-Fetvedt cycle, which was invented by Rodney Allam and Jeremy Fetfed from 2009, that's essentially what is at the heart of the Allam-Fetvedt cycle. You have an oxycombustor. So into that oxycombustor, you have natural gas, you have oxygen, and then you use the CO2 that you recycle from the process in that combustion process to create a synthetic air. And because you don't have any air in the process, you're not creating any NOx. So now you have those three components. You have the oxygen, you have the natural gas, you have the CO2, and the output of that when you combust that is extremely hot CO2 and water. And you then use that CO2 through a turbine, through an expander. You can generate power with a supercritical CO2 turbine, or you can use that CO2 in a reformer and use the heat from that CO2 to reform natural gas into products such as hydrogen.
Now, you said that the Allen-Fedford cycle, or you described this process as a cost-effective way, but it sounds like it's a whole new way of doing things. So how is this a more cost effective way? Do you not need to put infrastructure in place to go build this?
So the Allen-Fedford cycle is just like any other power generation facility in what I just described, in the fact that you have a turbine that generates power, and on the other side of that turbine, you've got the generator. The generator is creating power that is then going to the grid. Really, when you look at the Allen-Fedford cycle, the technology itself, and has been demonstrated, and has been also written in many pre-FEED studies and government supported grant papers, is as economical, if not more economical, than the latest class of CCGTs.
And where is the development of this? Where are we on the life cycle of this technology?
Originally, back in 2009, when the company was formed, when 8 Rivers was formed, the company then started to develop out the Allam-Fetvedt cycle. And what was spun out of 8 Rivers was now the publicly traded company Net Power, which is one of the big successes of 8 Rivers, is building that company and spinning that company out. And during the decade of the 2010s, basically 8 Rivers worked with Net Power to develop the LaPorte test facility, where there is a 25 megawatt electric, 50 megawatt thermal demonstration facility demonstrating the Allen-Fetvedt cycle, which was successful. And a lot of learnings were gained from that demonstration facility, which have then gone on to help Net Power build out their business and really, establish themselves now in the market to deploy their first serial number turbine and project, and get that out there, to, in whatever time scale that they're going to do that. Really, they're heading towards that now to develop that first technology on natural gas. 8 Rivers is still looking to develop internally the Allen-Fedford cycle based on solid fuels. And really, that 15 years that have gone by have really helped 8 Rivers develop the technology and really get to a point where the technology can be deployed.
Now, we're using 8 Rivers kind of as we all know everything you do. Maybe it makes sense to take a pause here and explain about what kind of projects and things 8 Rivers is doing. So you gave an example of a spin out, you gave an example of some technology. What are the kind of things 8 Rivers are working on?
So right now, one of the big things that 8 Rivers is focusing on is what we call 8RH2. And 8RH2 is a hydrogen production technology, which again uses that same oxy-combustion process and takes that and uses that to reform natural gas into syngas. And then from that syngas, we produce hydrogen. Again, we recycle that CO2 back round when it comes out of the CO2 convective reformer. We recycle that CO2 round, we harvest the heat, and we send it back to the combustor to be reused while sequestering some of that CO2. But essentially, we're using that process, which is the same process as the Allen-Fedford cycle, to then create, through the reforming process, syngas to hydrogen. That hydrogen can then be used to create ammonia, and then that ammonia can be exported into the market. And it's that technology that we're developing right now, and we're looking to deploy that in our first commercial project, which we've announced, which is Corman Clean Energy, which will be based in Port Arthur, Texas. We're currently going through the FEED study, building out the engineering, but also looking wider at infrastructure and how we actually deploy the project. Things like permitting, planning, working through all of those aspects, also working through port infrastructure in the Port Arthur area, working very closely with the local community around jobs that can be created for that local community, both in construction and in operation of the plant. And we're really working really closely with the strategic partners that we've already announced, such as Casale, on the technology itself, to make sure that we can deploy that technology in a 2027, 2028 timeframe.
Okay, so it's in the not too distant future, we'll see this for hydrogen. And I'm assuming, based on what you just described, just a master the obvious, green hydrogen. Yes.
No, so this is what, if you have to give this a color, the color you would give it is blue, because where the technology is based on reforming natural gas. So we're taking that natural gas, which means that we're using this. This would be color. If you have to give it a color, which I don't like to do, it would be blue. But what I would say is this technology captures 99.98% of the CO2 from the process. So this is a very, very ultra low carbon technology that's us being socially responsible for the process that we're going to put in place, that we are capturing and harnessing as much CO2 as is humanly possible in this process to make sure it is as clean as possible when we reform that natural gas.
And then what kind of scale are we talking about? So you're saying you're going to export it as ammonia, and we already move ammonia around pretty readily, so that's not too difficult to imagine. But what's the scale of this process?
So this particular project, the first phase of this project, will create 880,000 tons of ammonia a year, and we will capture 1.4 million tons of CO2, which we will sequester. That ammonia is obviously for sale onto the open market through offtake agreements. We're working on those offtake agreements now. A lot of people listening to this show will know that the current area of focus around the globe for ammonia are places such as Japan and South Korea, and they're looking to import that ammonia to use that as part of their decarbonization strategy in coal-fired power plants, where they can co-fire both the coal and the ammonia to offset the amount of coal that they're burning in their boilers.
When you say you're sequestering the carbon, what are you doing with the carbon? How are you sequestering it?
So through offtake agreements, again, there are many Class 6 wells which are either proposed or in place in the US. There are also offshore wells which are being created to sequester the CO2. So effectively burying that CO2 in a well underground where that CO2 will remain forever. Essentially, from our perspective, the project will contract with a third party who will offtake that CO2 and ensure that CO2 is safely sequestered.
Do you displace a technology in the ports today? Is it LNG that you're competing with? You're saying you're down on the Texas coast, or is this brand new facilities just adding additional capacity?
This is brand new facilities adding additional capacity. The project itself currently, as it is envisaged, is hydrogen to ammonia and ammonia for export. But that isn't to say that we couldn't also produce hydrogen in the region and ammonia. We can produce both. At the moment, our focus is on ammonia because of those markets that I spoke about in Japan and Korea. But locally, we could produce hydrogen, and we could then distribute that hydrogen into networks that already exist in the region for hydrogen to users in the region who use hydrogen.
And what kind of power or what do you need for this operation? Is it mostly chemical? Do you need renewable energy to create the ammonia and the hydrogen?
No, so what we basically need is a supply of natural gas. And it's that natural gas that is at the heart of both the combustion process to create the CO2, and that natural gas is also the product which is then reformed into the syngas, which then becomes hydrogen. The other important aspect is the power that we require in the area, and obviously, you know, there's a lot of news around the limited amount of power in the region, but we've been working really, really closely with Energy Texas and really closely around their step ahead plan to work with them to understand what capacity will be available to us in the future. And we're assured that we will have the power in the region to supply what is a very, very large scale facility producing that ammonia. So really, the infrastructure is key. I think the other area of infrastructure that's key as well that we're working on is the port access and ensuring that we can actually get the ammonia from our facility through a 3.5 mile pipeline that takes us to the port, which then allows us to temporarily store the ammonia at the port before loading that onto a vessel, and that vessel then making its way to its destination to the user that buys the ammonia from us.
And do you have concerns about the ships? Have you have hydrogen or other technologies that aren't running bunker fuel in the ships, or are we just using whatever ships are available?
So the ships themselves, that's currently something that's being looked at as to how those ships would be powered. Um, there's no real decision around that at the moment. That's something that we're speaking with logistics providers around. I would say predominantly those ships will be, they will be standard ships, just running on normal bunker fuels in the short term. Obviously, then transitioning those vessels to other fuels. But we're in open dialogue with shipping companies around that.
Makes sense. What are, I mean, you're opening it, I assume, in Texas because of the North American availability of natural gas. Are there other markets that you're looking at this technology where this makes sense?
Yeah, the technology makes sense in many regions of the world. I think the big focus now and the big focus for everybody is the subsidies in the US around 45Q, 45V, all brought through by the Inflation Reduction Act. That's the real driver here, is that's what's driving everybody to sort of look really, really closely at the US, because the Inflation Reduction Act really allows you to use the policy for what it is. Whereas in other regions of the world, some policies are more restrictive, or they've not been thought through yet, or you know, there's other, shall I say, boxes to tick that are much more difficult to tick, or not mature enough yet. So initially, deploying the technology in the US makes a lot of sense because of the ease of the policy that is around the Inflation Reduction Act. Once we've then deployed the technology in the first instance, it then becomes easier to deploy the technology again and again and again and adapt that technology as other regions' policies mature.
When you're talking about deploying the technology, are you talking about deploying it as licensing, or are you talking about deploying it as Eight Rivers or whatever company you established to do this?
So initially, the first project will be Eight Rivers. The first project, Cormorant Clean Energy, currently is 100% owned by Eight Rivers. And once we've deployed the technology, which many will see as a first of a kind technology, we do not see it that way. And we can talk about that a little bit more later in the show. But right now, once we've deployed it once and we've proved to the world that this technology works and this process works, we'll then start to look at licensing that technology and licensing that technology to other companies who can deploy the technology. The idea here, Chris, and the idea behind it, the company, is if we were to deploy every single project, we wouldn't deploy enough to make a difference. We really have to deploy in a licensing model so that many people can deploy this technology, not just Eight Rivers.
So describe what one of these facilities is like. What will it look like? And you said you'll talk about the technology, but maybe it makes sense when you describe a little bit. If one of these were opened up in the port and I drove by, what would it look like?
It would look like any other chemical refinery that you would see. You wouldn't really notice. You couldn't look at it and say, "Haha, that is an Eight Rivers 8RH2 facility." It would just look like a series of columns. There would be an air separation unit, which again just looks like a large square box to many people. Um, you know, there's nothing really that you would see that you would recognize uh, as this technology. It looks just standard columns, standard refinery, flare stack, just like any other refinery. I would say it is smaller for its scale when compared to other hydrogen technologies, but there's nothing really different about it.
Now, is this mostly automated? Is it a pretty light crew working there, or how many folks tend to work at a facility like this?
Yeah, we envisage that in operation there'll be around 90 jobs will be created in operating this facility across the facility, which is very light. Um, that is born about the way we're going about the control system for the technology and how we're doing that with our partners. Casale means that we can look at that in a different way. Again, not following the norm of how facilities have maybe been run before, but looking at how we can run it differently and how we can use things like remote monitoring and different systems that we can look to use that help us make it a better working environment for the people who operate the plant, and at the same time make sure that it's also safe and run reliably, and have all of those systems in place that allow us to use that sort of remote monitoring as well to operate the plant.
Now, you said that the technology, some will perceive it as new, others will, once you explain it, see that it's not really cutting edge or brand new across the idea. Maybe you can unpack that a little bit and help me understand what you meant by that statement.
Yeah, certainly. So if you look at any hydrogen production facility, or any modern day hydrogen production facility, they're all based around autothermal reforming, or they're all reforming processes. And this is no different. It is a reforming process. But the way in which we carry out that reforming is to take the CO2 and use that CO2, use the heat from that CO2 in the reformer with the catalyst and the natural gas to create the syngas. And that in itself is not that's not novel. Yeah. The novelty is the CO2. Any reforming process uses heat and a catalyst to create syngas, to create hydrogen. So there's nothing novel per se, other than we're taking that heat from CO2. And the rest of the system, when you look at it, is pressure swing absorbers. It's secondary reforming. So whether that's gas heated reforming or oxygen secondary reforming, you've got heat exchangers, you've got compressors. So there's a lot of standard kit that's in the process that's all been proven at that scale before. There's a reformer that's at the heart of it, which we call the CO2 convective reformer. But again, as I just said, it's just a reformer. It's just that it's getting its heat from CO2. That's the only difference.
Now, do you envision? You said that you wouldn't be able to scale up to meet the demand if you look at hydrogen or ammonia, but it doesn't matter how you ship the molecule. Um, how do you envision the future going? Do you see plants doing this? Do you see folks doing other methods? Are there many paths to get there, and that you're just one of them, or do you expect a significant part of the market to go this direction?
I expect that the market around the use of natural gas to create hydrogen and ammonia, and again, given it a color, which I don't like to do, but it's blue, will all be around this process, a reforming process. It has to be. What I think this does, and what I think we at Eight Rivers are doing, is our carbon capture rate, which is at 99.98%, is currently one of the highest, if not the highest, carbon capture rate in a blue hydrogen reforming process. What I see that doing is I see that driving the others to achieve the same. We went through a period in the past 5 years whereby a lot of companies were producing the same technology. It will capture 94, 95%, and really not driving to get that extra 5% because it's diminishing returns. It doesn't really give them anything. But I think now what we see is that now you have subsidies in place that are rewarding you for capturing more CO2. And because companies like ourselves are driving to that socially responsible place of capturing as much CO2 as possible, in an economical way, our competitors will drive to do the same. And we're already seeing some of our competitors start to have literature out in the market where they're stating 99%, 98%. And that's a really good thing to see, because previously that wasn't there. And you sort of think to yourself, well, you're helping drive the market to a better place.
Other than the subsidies or the IRA benefits, you also talked about offtake agreements. Are you pre-selling some of your capacity? Is that part of your goal? Or I mean, because ammonia is pretty much a commodity, right? So are you finding an appetite in the market to pre-buy it?
Yeah, I mean, to get any project such as ours, through financial investment decision, you've got to have an offtake agreement for the product. So there is a lot of appetite in the market now, a lot of appetite from Japan and Korea, and others for this product. Obviously, you've got to be able to sell that product as cost competitively as possible, and it's a very, very hot market. Ammonia has been around a long time. It's not something that's new. There is an ammonia market already. There are some very big players in that market that the people who haven't played in that market before are now stepping into. If you look at in the Gulf region and you look at how many projects are anticipated, I think it's up around 24, 25 projects. That's a lot of projects. And not all of those projects are going to go ahead, but all of those projects need somewhere to send that ammonia. And that's where you start to drive cost. And that's where our particular technology really, really plays to a strength of low capex, because we don't have the amines at the back end. We're not stripping out the CO2. We are, as I said at the very beginning, creating that CO2 in the first place. We are putting that CO2 to very good use through heat and heat recovery and reforming, and we're then sequestering that CO2. So that means that we had the problem in the first place, and we turned that problem into a solution, and therefore we don't have that large capex. We have a very, very competitive price to deliver ammonia to the market.
Well, I think it's interesting hearing about the conversation, hearing about your projects. If our audience wanted to find out a little bit more about what's going on, where resource would they go to? Where would they go on the web to find out more about what you all are doing?
So they can go to our website. So they can go to 8rivers.com. That'll tell them all about the company, and it will have all the links there to all of the technologies, to our projects, to our microsite around Cornwall Clean Energy. There's plenty to read on the internet as well that's been written by others. So if you just want to go onto good old Google, type in 8 Rivers 8RH2 or 8 Rivers Allam-Fetvedt Cycle into Google, as soon as you hit return, you're going to get a lot of results. If you then click on the news tab, you're going to read a lot of news articles about 8 Rivers and what we're doing in the clean energy, clean fuels, and decarbonization space.
Well, Steve, I want to thank you so much for coming on the podcast today. It's been educational. I look forward to following you guys through 2027 and beyond to see the development in Texas. Thank you so much for being a guest.
And thank you, Chris, and thank you to all the listeners. And if anybody is listening to this and thinks that company sounds interesting, I really want to learn more, they can always just reach out directly. Always willing to speak to anybody about our technologies or the company in general.
For our audience, we hope you've enjoyed this episode of the Insider's Guide to Energy. Please take a second to like, add comments, follow us, and subscribe to us on YouTube. And we will see you again next time on the Insider's Guide to Energy. Bye for now.